Assalamu alaikum, grade 10 computer science students. Today we will start lesson number 5. This lesson is about von Neumann architecture. Let's start. This man, von Neumann, a physicist and mathematician, proposed a computer architecture design in 1945. Later on, this design was known as von Neumann architecture. Before von Neumann, if you want to instruct a computer, so the program will run only once on that computer, and there was no concept to store that program. Von Neumann for the first time proposed this architecture where computer program and data could be stored in memory together. The von Neumann architecture is based on stored program concept. It means you can store the program as well as data in the same memory. So this was a great invention. This was a great change in the architecture of computer, and the modern day computer is mainly based on von Neumann architecture. This design is still used in most computers produced today. Look at the picture. You can see there is a central processing unit, and there is input device, there's output device, and there is memory unit. So according to von Neumann architecture, the main parts of the computers were central processing unit, and the central processing unit consisted of control unit, arithmetic and logic unit, and immediate access storage or memory unit, and registers. Central processing unit is the brain of the computer or the main processing unit. Control unit is responsible to control other parts of the computer. Arithmetic logic unit is used for arithmetic and logical operations. Arithmetic operations includes addition, subtraction, multiplication and division, and logical means the comparisons like equal, less than, or greater than, or less or equal. Immediate access storage was used to store the instructions and program, and the registers we will discuss in a while. It is the storage location inside the processor. And then there is a memory unit that is used to load the programs and instructions. And of course there were inputs and outputs as well. Now let us discuss the central processing unit in detail. It's the main processing unit. It is also known as processor. CPU consists of control unit, arithmetic and logic unit, immediate access storage, or you can say memory unit, and registers. The other units like input and output device are used to communicate with the other devices like keyboard and mouse. Okay, let's go back to the central processing unit, and we will discuss a bit about the central processing unit. As you can see, central processing unit consists of the control unit. And what is a control unit? The control unit controls the flow of data through CPU. It controls the interaction between the different parts of the CPU, and it tells other components. It gives instruction to other components, as well as it links the hardware and how to respond to different instructions. As I told you before, arithmetic and logic operation unit is used for arithmetic and logical operations. Arithmetic operations includes addition, subtraction, multiplication, and division, and logical operations includes comparisons like less than or equal, less or equal, greater or equal, and comparisons like not equal. The immediate access storage, this is inside the CPU, and it is used not only the data but also it holds the instructions. It is used to process the data, and it is also known as CPU memory. The registers are the internal memory location within the CPU. They temporarily hold the data and instructions during processes. We will discuss different register types shortly. The input and output units are used to communicate with the other devices, and they play like a supportive role with the other components. The different registers that are used, and I have written the description so that you can read it clearly. The first register is memory address register. It's clear from the name, this register holds the memory location of the data that needs to be accessed. What it means, if you need to access any data, so this register will be storing its location. Memory data register. This register holds the data that is being transferred. Okay, so the first register will hold the location of the data, but this register is used to store the data that you want to transfer to or from memory. Accumulator. This register holds the intermediate arithmetic and logical results. So we talked about the ALU, and accumulator is actually the register that is used for that arithmetic and logical results. Program counter. This register contains the address of the next instruction to be executed. Once one instruction is executed, so from where the computer will get the address of the next instruction, it is from the program counter. Current instruction register. This register contains the current instruction during processing. When the computer is processing the information, the current instruction register will be storing the instruction that are required to be processed. Okay, let's talk about the buses. Buses are the means by which data is transmitted from one part of a computer to another, connecting all major internal components to the CPU and memory. Like you travel through roads and highways from one place to another, so the buses are like the highways that are used for transfer of data. Different type of buses are used, like we have the address bus, we have the data bus, and we have control bus. The address bus carries only the addresses of the data. The data bus carries the data between the processor memory unit, and the other device is control bus carries control signals or commands from the CPU in order to control and coordinate all activities within the computer. Let us talk about it. Address bus is from the name, it's clear that it carries only the addresses. Data bus carries the data, and control bus carries the signals or commands from the CPU to the other parts. So each bus is used for different purposes. If you have any questions regarding today's lesson, you can send me a personalized message on my WhatsApp.